Welcome everyone. Let's learn implicit differentiation. We all know how to differentiate a function if it's given to us as y is equal to f of x. For these forms, everyone can evaluate dy by dx. However, some functions are defined implicitly, which means you cannot leave y alone by algebra. Therefore, you cannot differentiate according to the methods you learned. For example, x cubed plus y cubed is equal to 6 multiplied with xy. You cannot leave y alone, but still you can figure out the derivative. We will use the method called implicit differentiation, which tells us to differentiate both sides with respect to x. After that, we solve the equation for dy by dx, so we will leave y derivative alone, and we will get a function. Example, find y derivative if x cubed plus y cubed is equal to 6 multiplied with x multiplied with y. Clearly an implicit form, because I cannot leave y alone with algebra. Therefore, I have to differentiate this implicitly. How am I going to do that? We will respect everything, both sides, with respect to x. X cubed is differentiated, 3x squared, plus. Now, what is y cubed? I have to think y as a function of x. Therefore, now I have to differentiate this according to my chain rule. First, I differentiate the functions out to the power 3y squared, then I differentiate inside of it, which is y derivative, is equal to, I need to differentiate right side as well, 6. This is differentiating multiplication, therefore 1 multiplied with y plus x multiplied with y derivative. I can divide both sides with 3. X squared plus y squared y derivative is equal to 2y plus 2xy derivative. Now we have to figure out what y derivative is. With algebra, I can send this term to the other side, same for this term. X squared minus 2y is equal to 2xy derivative minus y squared y derivative. Factorizing the y derivative will give me y derivative multiplied with 2x minus y squared, which is equal to x squared minus 2y. From here, leaving y derivative is really simple. Y derivative is x squared minus 2y, dividing both sides with 2x minus y squared is my answer. Another example, we want to find y derivative again. You can really see, it's really easy to see you cannot leave y alone. It's really painful. Sine x plus y, maybe some trigonometric properties, but there's a y squared also. You have to differentiate implicitly again. Derivative of sine x plus y. This is a composite function, so I start with outside of it, cosine x plus y. Now I multiply it with derivative of inside 1 plus y derivative. Again, I assume I think y as a function of x, so therefore I differentiate the power, then I differentiate inside of it. Y squared multiplied with cosine x, derivative of multiplication. Let's differentiate y squared. 2y, y derivative, again the same reason, multiplied with cosine x, plus cosine x differentiated as negative sine x, minus sine x, y squared. Let's see how can we leave y derivative alone with algebra. Cosine x plus y plus y derivative cosine x plus y is equal to 2y y derivative cosine x minus sine x y squared. I will send this term to the other side and send this term to the other side. Cosine x plus y plus sine x multiplied with y squared is equal to 2y multiplied y derivative cosine x, it's a plus, so minus y derivative cosine x plus y. Again, factorizing y derivative, 2y cosine x minus cosine x plus y is equal to cosine x plus y plus sine x y squared. It's really easy to leave y derivative alone from here, which is equal to cosine x plus y plus sine x y squared over 2y cosine x minus cosine x plus y. Sometimes differentiating can take some time, but it's not easy. We use the same rules. We just have to be careful with y. Differentiating y is why should we be careful? Again, implicit form. How do I know? I cannot leave off y alone. There's arc cot y. There's y is equal to x. What is dy by dx? Differentiating left side is really simple. 1 is equal to derivative of y derivative is derivative of y is y derivative plus now r cot y. We learned in our inverse trigonometric function derivatives videos, this is equal to negative 1 over 1 plus x squared. But since this is y, we are differentiating an implicit form. This will be 1 over 1 plus y squared multiplied with y derivative. Why? Because inside we assume y is a function of x. I want to leave y derivative alone. 1 is equal to y derivative. Most of the time, you will just factorize y derivative, and according to then, after that, it's really simple algebra. What do we have? 1 minus 1 over 1 plus y squared, right? Let's do some algebra again. 1 plus y squared minus 1 over 1 plus y squared, which is equal to y derivative multiplied with y squared over 1 plus y squared. 1 is equal to y derivative multiplied with y squared over 1 plus y squared. Again, leaving the y derivative alone is really simple. If we multiplied both sides with 1 plus y squared over y squared, I'm just gonna call this px, and I will multiply this side with px too because I don't have space here. Y derivative will be equal to 1 plus y squared over y squared.